So I mentioned we can take this 5-number summary information and make a nice graph out of it called a box plot. And we'll look at some examples of that now. But in general, what a box plot looks like is this key interquartile space makes the box. And then there's a line in that box for the median. Notice the median, this data is skewed, so the median's not necessarily right in perfectly symmetric. That median would be right between those quartiles. But so even with the box alone, you can get some information about skewness there. And then these are also sometimes called box and whisker plots, because then we draw lines out each direction. And let's say this way there was some outliers. Remember this definition of what we're going to call an outlier? Let's say out this way there was some outliers. Well, this line would extend to the last data value that was not an outlier. And then each outlier, let's say there was a couple outliers on this side, they would get stars or dots usually in most graphing software. If you're doing it on a calculator, it'll let you choose circles or boxes or something for that. And then if there's no outliers, let's say there was no outliers on the low end, then the whisker just extends all the way out to the min. So you could have outliers on both sides or no outliers, in which case these whiskers would just go all the way out to the max and the min. The nice thing about box plots is you get some quick information about where these chunks of data are and what kind of skewness you got going on and what kind of outliers you have. So it gives you a quick snapshot. What I want to do now is move to the applet, and we'll look at creating a box plot. And actually, one of the most powerful things about a box plot is the ability to stack them so you can compare data from different populations. So we'll look at that. So what I have here is just the Descriptive Statistics applet. This allows you to draw box plots or histograms and just get the basic information. We used this early in the semester. And I want to give it data from 2 populations. So we can actually, it'll do stacked box plots. And notice there's a checkbox here for stacked. And you can actually switch which order the info's in. Notice what you have to have is if you do include headers, your headers, and then the quantitative information's going here, and what the categories are going here. So I'm going to do this example from the text, which is prices of haircuts from men and women. Here's the data how I had it originally. Here's the women haircut prices and the men haircut prices. But to put it in, you really have to have it as ordered pairs of the category and the price, or the quantitative amount. So I've selected those, and now I'll clear out this data and paste in. So now we've got it in there. It should be able to interpret that in the way we want. So let's click on Use Data. And by default, the dot plot comes up, but we would like the box plot. And it just sets it on top. When you're ever drawing a box plot yourself, be sure to include an axis. A box plot is not as informative if we don't know what the numbers are. So here they've put the axis in. And there was the old just dot plot data, and here's our box plot. And so here's up top is the box plot for the men, their haircut prices, and the box plot for the women. And now you can see what I mean about nice for comparison, so we can see they kind of share a minimum. If we go back to our data, there were some 0 prices in here for women and some 0 prices in for men, so we're seeing that. But we can also see that the men prices are very tightly packed on the low end. And remember, the box represents the middle 50%. So think of that as the typical stuff, that big chunk in the center. And it barely touches the low end of the middle chunk for the women haircut prices. So what we're seeing is that The 50%, or actually more when you include that, is less than this middle 50 for women. So the men prices are drastically less. In this case, there was not even a whisker on the high end for men. We see some outliers here. It looks to be in the 70s or 80s range. If we scroll down in our men data, that must be that 60 and that 75 that we're seeing. But this stuff was so tightly packed in the middle that 23 is still in the box, and then the first thing outside the box is an outlier. So there's not even a whisker. This is really tightly packed data with just these two outliers out. Whereas in the women data, the box ends at about 60. If we go back into the women data, not sure, maybe 60, 65. And then the tail, that whisker runs all the way up through this 110, 120, I guess, 120. So there we're at Q3 with 120. And then notice these outliers are all the same. So the way this software does is it just puts a single dot there. You may do a box plot if you just Google an applet. Some people like to stack those. So you might see 3 dots stacked up, so you can see that, oh yeah, not only is there an outlier there, there's 3 outliers all with the same value. So you get an idea how you can kind of quickly visually compare the distribution of data when you stack these box plots. And if you want to, just for your information, you can add on there the mean, the median, if you want that information when you're doing the box plots, as well as the standard deviation if you wanted, interquartile range. What's nice is it doesn't just give you the interquartile range, it gives you how it was calculated. So there's your Q3 and your Q1, Q3, Q1. So they did the subtraction and got their interquartile range. Notice men have a much smaller interquartile range than the women, so that there's less spread going on here. And we see that in the standard deviation, our old way of measuring spread. The men's standard deviation is much smaller than the women's there, almost half. And when they put the arrows on here, you can kind of see the skewness. The men, that's skewed a little bit. Women's skewed a little bit more. That mean, in both cases, the mean is pulled a little bit to the right, which kind of makes sense for a lot of data. Often 0 is a theoretical end to what your data could be, because negatives don't make sense in a lot of cases. So often if there's outliers, they're on the high end. Not always, but so that will often your skew is to the right. So this descriptive statistics is a great way to get a quick stacked or just a single. You don't have to do stacked. You can just give it a set of data without labels and just uncheck stacked, and you'll just get a single box plot.